So in this video, we're going to be working with the 6 trigonometric functions. Trigonometry is the study of the relations between angles and sides of a right triangle. We have six of them. We have sine, cosine, and tangent, and then cosecant, secant, and cotangent. The last three, cosecant, secant, and cotangent, are the reciprocal of sine, cosine, and tangent. Now, in a right triangle, we have two angles that are acute, and then a right angle. My side opposite to the right angle, as we know, is the hypotenuse. Then from theta, that is this angle here, theta is just a Greek letter. We usually use Greek letters in trig as variables, so we can either tell them apart from the word tangent and so on. So from theta, and again, on this picture, this is going to be the opposite side. And then this is the adjacent side, because it's next to the angle, and it's the side that is forming the angle with the hypotenuse. The adjacent side is forming the angle with the hypotenuse. Now, on this picture, again, given that theta is this is the adjacent, and this one is the opposite. But if I flip it around, so if I say that this is theta, then from this is that angle, then this is the adjacent, and then this is the opposite. So given that we have that sine of theta, it's going to be the opposite over the hypotenuse. Cosine of theta is the adjacent over hypotenuse. Tangent of theta is opposite of adjacent. And then as you can see here, again, cosecant is a reciprocal of sine. So in this case, I'm just flipping the fractions. So that means that cosecant is hypotenuse over opposite. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And then cotangent is the reciprocal of tangent, that is adjacent over opposite. One recommendation, and this is how I learned it when I was in school. I know that my pair is one started with S, the other one with C. So sine is reciprocal of cosecant, and cosine is reciprocal of secant, right? One started with C, the other one with S. Okay? And this one, so it's a little bit easier because it's tangent and cotangent. Okay, so on this one, let's see that information that we just discussed in exercise. We want to evaluate all 6 trig functions. So I'm going to start with finding and identifying where's my angle. So this is my angle here. So that means that from this angle theta, my opposite is on the opposite side of the triangle. So this is going to be my opposite. This is going to be my adjacent, and this, of course, is the hypotenuse. Remember that, this is the adjacent, right? So start with sine of theta. So sine of theta is opposite over hypotenuse, so that means that I got 4 over 4 square root of 5. This 4 cancel out, so this becomes a 1 up here. So I got 1 over the square root of 5. Now I'm going to rationalize, so that means that I'm going to multiply here times the square root of 5. So whatever I do in the denominator, I got to do in the numerator. So that becomes the square root of 5 divided by the square root of 5 times the square root of 5 is the square root of 25. That's 5. Again, cosine is adjacent over hypotenuse, so 4 square root of 5. I'm going to simplify first, so this becomes a 2, this becomes a 1. So I got 2 over the square root of 5, and again, I'm going to rationalize. So equals 2 square root of 5 over 5. The next one is the tangent. So tangent is opposite over adjacent. So by simplifying this, this is 1/2. Now, I'm going to find my reciprocals. So I get cosecant of theta is hypotenuse over opposite. So this is just the square root of 5. Secant of theta is hypotenuse over adjacent, so hypotenuse over adjacent. So it's 4 square root of 5 over 8. Again, I can simplify here by 4. So this is the square root of 5 over 2. And then the last one, cotangent. Cotangent is the adjacent over the hypotenuse. So that means that I got 8 divided by 4. So that means that this is 2. See number 2. Again, tangent is up here. So that means that this is my opposite. This is my adjacent, and this is the hypotenuse. To help you remember which one is sine, cosine, and tangent, we can use this acronym, right? SOHCAHTOA, right? Where it says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then once we know that one, it's easy to find the other one because again, it's just a reciprocal. So let's start here with, again, sine of theta, cosine of theta, tangent of theta. So sine is opposite over hypotenuse. In this case, I cannot simplify. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Then cosecant, again, is the reciprocal of sine, hypotenuse over opposite. Secant is 17 over 8, and then cotangent of theta equals 8 over 15. Okay, so the next one. One recommendation that I can give you here, especially in this exercise that is clearly we have a common factor of 4 on every single number, is to start by simplifying those numbers. Right? I simplify everything here by 4. So 20 divided by 4 is 5, 16 divided by 4 is 4, 12 divided by 4 is 3. So that way, when I go to my fractions, I don't have to simplify on everything. If I simplify at the beginning, once I write my fractions, I don't have to simplify again. So in this case, again, this is opposite from this angle. From that angle, this is still the hypotenuse, and then this is the adjacent side. Keep in mind that on every right triangle, your hypotenuse is the largest side of the three, or the longest side of all three angles, all three sides. Right? So in this case, sine is 3 over 4, that is the opposite over hypotenuse. Cosine is 4 over 5. Tangent is 3 over 4. Cosecant is 5 over 3. Secant is 5 over 4, and cotangent is 4 over 3. Now let's see what's happening when I'm missing one side. So like this one, I got 3, 4, and I'm missing my hypotenuse. As you should remember from geometry, to find a missing side of a right triangle, we use the Pythagorean theorem, where C is always the hypotenuse, then X and Y, because I'm adding, it actually doesn't matter the order, but C is always the hypotenuse. So in this case, I'm missing the hypotenuse, so I get 3 squared plus 4 squared equals 2, let's name it h squared. So I got 9 plus 16 equals h squared, so 25. And then the square root here of both sides, h is 5. That means that this equals to 5. Now, I got all my information from my angle. This is going to be the opposite, adjacent, and the hypotenuse is 5. So we can go directly to sine of theta equals 2 opposite over hypotenuse. Cosine of theta equals 2 adjacent over hypotenuse. And then tangent of theta equals 2 opposite over adjacent. Keep in mind the following. This is very important when you write it. The trig function, they don't exist by themselves. You need the angle. So you cannot just write sine equals to 4 over 5. You need to write sine of theta. Or if we have a number that we're going to see it in another lesson, if we know the angle, then we can plug in there a number. But you cannot just write cosecant equals to 5 over 4. We need that angle here. Again, cosecant is the reciprocal of sine. In this case, whenever we don't have the square root, it's easy. Just flip each fraction, secant of theta. Again, I'm going to flip that fraction 5 of 3 over 5. And then cotangent of theta, I'm going to flip the fraction 4 over 3 to 3 over 4. See the next one. Again, I got 25. I'm still using x squared plus y squared equals 2 c squared. Now, the hypotenuse is this 25 here. So that means that I got 20 squared plus y squared equals 225 squared. So I get 400 plus y squared equals to 625. So y squared equals to 225. And the square root here, y equals to 15. So that means that this side is 15. Again, before I start, I got a common factor here of 5. So I'm going to divide everything by 5. So that way I don't have to work. See, it's going to be very similar to the other one. So again, this from my angle up here, this is the opposite, adjacent, and hypotenuse. So go again, sine of theta is 4 over 5, opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. So I got 3 over 5. Then tangent of theta equals 2, 4 over 3. And then again, cosecant of theta is the reciprocal of sine. Secant of theta is the reciprocal of cosine. And then the cotangent of theta is the reciprocal of tangent. So again, in this case, I get x squared plus 10 squared equals to 5 square root of 5 squared. This is my hypotenuse, right? So on this case, I'm simplifying. Right? This is the same as 5 squared times the square root of 5 squared. This here, they cancel out right here. So I got a 5, and then 5 squared is 25. That's 125. From there, I got that x equals to 5. Now, this, from my angle, adjacent, opposite, hypotenuse. So, and again, I can simplify by 5 here. I can simplify by 5 because I got this 5 out here. Not the one inside, just the one outside. So I got that 5 right here. So by simplifying by 5, this becomes a 2. This becomes just square root of 5. And then this becomes 1. So that means that sine of theta is 2 over the square root of 5. So I'm going to rationalize here. So I got 2 square root of 5 over 5. Then cosine of theta is 1 over the square root of 5. Again, I'm going to rationalize. Equals 2 square root of 5 over 5. Then tangent is opposite over adjacent. So it's 2 over 1. Then cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And then cotangent is adjacent over opposite. And that's it for this lesson. May the force be with you.